Alright guys, hopefully yesterday's lesson was actually pretty easy because today's is going to be essentially about the same thing. Because again, we're still talking about lines, equation of lines in these here. Now 2.6, we're going to start dealing with some other functions like cubics, absolute value, quadratics. So quadratic functions or absolute value functions, or cubics to the third power. These graphs and how they move or transform and graphing them. And a lot of that with this here, just like with linear equations, we just need points. Once we have the points plotted, we can graph the function. And that's really all there is to it. And luckily, Alex is very helpful in plotting a lot of these here. Because if we have enough points with it, well, same with radical functions, we have at least 3 to 5 points. We put them in, plot them. The calculator or the actually program will do it for us. We don't have to physically graph the whole thing. So that is nice. But what we're looking at today is equations of lines, point slope form. Now, we did talk about this yesterday, this version of the equation, and it's very helpful if we're given a point and the slope. We plug it in and solve for y. Now, before we dive too deeply into that, there's one thing I do want to talk about, and it's finding the equation of a vertical or horizontal line given a point. So a vertical line is a line that goes straight up and down. So this here is not in great perspective, but it will serve for this case in point. Is this point here, the point 5, 9, if we wanted to draw a line or have a line going vertically through it, it would be the line going straight up and down. And how would we write the equation for said line? It would be what? It's all the x values equal to 5. That's actually it. That is the vertical line. That's the equation of the vertical line passing through the point 5, 9. So if we also wanted the horizontal line passing through this point, it would be what? It'd be our equation what? Y equals 9. Horizontal is y equals, vertical is x equals. That's literally it. It seems like it would be or has to be something more complicated. There has to be something more to it than this, but that's literally it. Because even if we go back to this here, using the point 5, 9, so we can say y minus 9 is equal to m times x minus 5. For a horizontal line, the slope is 0, because when it doesn't have a rise up or down, the slope is 0, so this whole side becomes 0. Add 9, y is equal to 9. And we can do that, especially if it's horizontal. Now, vertical, all this falls apart because the slope is what? Undefined. We don't have a value. There is no value we can plug in for it because it's going straight up and down. So using this for undefined slope doesn't work because it is undefined by definition. But we can do it with horizontal and show mathematically that y equals 9. Now, let's look at this here. Use the point slope formula to find an equation passing through the point 2, negative 3, and having a slope of negative 4. We're literally going straight back to this here. Our y value from the point is negative 3. The slope given to us is negative 4. and the x value is 2. Plugged it all in. Now we just need to get y by itself. We need to get it in slope-intercept form. So there's two things we can do. One, negative 3 is going to be plus 3. We can also distribute the negative 4, giving us negative 4x plus 8. Last but not least, we can subtract 3 from both sides, telling us y is negative 4x plus 5. And that's it. Now these also are some of the easier ones to graph just from the beginning, because they gave us a point and the slope. So if I just wanted to graph it, all I got to do is plot the point to negative 3, use the slope of negative 4, which would be down 4 right 1, or up 4 left 1, and you have the equation of the line graphed. But that's it. Questions on this here? Use the point slope formula to write an equation of a line passing through the points 4, negative 6, and negative 1, 2, and write the answer in slope-intercept form. Now, we didn't talk about two-point form. There is two-point form equation of a line. However, I don't like it. It's not that there's anything intuitively wrong with it. I will show you what it is. Most likely, y'all won't have as much pleasure or like it as much, because it does look very similar to point slope, except we don't use m for slope. We plug in the formula for slope. I don't like it because there's a lot going on here. Because all we have to do instead is, well, we can take that out. That's a lot going on there. And just leave it as m. And normally what I will do is I'll calculate the slope off to the side, because all we're doing is subtracting the y values. So 2 minus negative 6 over negative 1 minus 4. And hopefully at this point we're very used to calculating slope. So since we're given 2 points, we know we'll need to calculate the slope. We can plug this in a calculator and it'll give it to us. We don't have to write it out. Because 2 minus negative 6 is the same as 2 plus 6, which is 8. Negative 1 minus 4 is negative 5. So negative 8/5 is our slope. Now at this point we can pick one of these 2 points to use. I'm just picking the point 4, 6. And now at this point here we can simplify and get y by itself. So y minus negative 6 is the same as y plus 6. Here we can distribute the negative 8/5, which will give us negative 8/5 x, plus negative times a negative is plus, 8 times 4 is 32 fifths. Because whenever we multiply a natural number or an integer, really it'd be an integer with a rational number, we multiply with the numerator, so 8 times 4 is 32, and it's going to be over 5. Or we can just plug it into a calculator and let it do it for us. Now lastly, we do need to get y by itself, so we're going to subtract 6 from both sides.
Teachers, at this time, please release all students who are going to NTC to interview to go to breakfast. Only NTC interviewees.
Yep. But this here is the equation. That's all we have to do. We have to subtract 6 from it. Now, I'm not expecting y'all to be able to just do 32/5 minus 6. It's 2/5. Because as we can do 4 times our 8/5, which will give us 32/5, minus 6 is 2/5. And really the reason we get to that is because, again, for us to be able to add or subtract fractions, we need the denominators to be the same. So the denominator has to be 5. 6 times 5 is 30. 32 minus 30 is 2. And luckily with fifths, 5 is not a bad number to work with. But if we start working with others, 13ths, 11ths, they get kind of funky to deal with. And utilizing the calculator is never a bad thing, because as long as we plug it in, it'll give us the correct answer a lot faster than we can do it by hand. Any questions on this here? Now, if you're trying to graph this, trying to graph 2/5 on the y-axis is probably a challenging thing to graph because it's not a nice whole number. 8/5 wouldn't be too bad, but if we're trying to use negative 8/5 going from 2/5, it might be a little challenging. But again, how many points do we need to graph a line? 2, yes? They did give us 2 nice points to start with, yes? So we could actually plot those 2 points and graph the line. Any questions on this here? Parallel and perpendicular. 2 lines are going to be parallel if they have the exact same slope. If they have the same slope, then they're parallel. If they are perpendicular, M1 and M2 represent the slopes of 2 non-vertical perpendicular lines, then M1 is equal to negative 1 over M2, or equivalently, the product of the 2 slopes is negative 1. Now, when we covered this in Algebra 1, and we talked about it some in geometry, and I think we talked about it a little bit in Algebra 2, we didn't talk about it this way. We said that they were the opposite reciprocals. That means we change the sign and flip it. Change the sign and flip it. So if one of the slopes is negative, I'll just pick 8/5. Its perpendicular slope, we change the sign from negative to positive and flip it to 5/8. Change the sign and flip it. But if we did multiply these together, negative 8 times 5 is negative 40. 5 times 8 is 40. And 40 divided by 40 is 1. It would be negative 1. That's all it's saying. M1 times M2 is negative 1. Opposite reciprocals. Write an equation of the lines passing through the point negative 4, 1 and parallel to the line defined by x plus 4y equals 3. Write the answer in slope-intercept form and in standard form. So standard form is this here. Standard form is our ax plus by equals c. Slope-intercept form is our y equals mx plus b. So we're going to want it in both forms here. Now, from our original equation, x plus 4y equals 3, there's only one main thing that we need from it, and that's its slope. We need to know what the slope is. So to get that, the easiest thing to do is to get y by itself. So the first thing I can do is subtract x from both sides. But to tell us that 4y is equal to negative x plus 3. And at this point here, we're going to divide everything by 4. Telling us what? Y is equal to negative 1 over 4x. Yes? So what is the slope? Negative 1/4. Now we also have plus 3/4. Now the 3/4 and really the rest of it only is important if it asks us to graph the original equation and the line parallel to it. If it asks us to graph both, then it's kind of important to finish this out. But again, the only piece that doesn't ask for that is the negative 1/4. And a lot of the times when I'm doing these here with parallel and perpendicular, I really figure out what the slope is and then kind of leave it be. I don't care about the rest unless I have to actually graph it. Now the reason this is helpful is because A, we're trying to find the line parallel to it, which means our slope for our new line is negative 1/4. And it passes through the point negative 4, 1. Personally, I always start with our point slope form, and we can go from there. Now our point that they gave us is negative 4, 1. So the y value is 1, our x value is negative 4, and our slope is 1/4. Well, the negative and negative does make a positive, and we're going to distribute the negative 1/4 through. So we have y minus 1 is equal to negative 1/4 x. Negative 1/4 times positive 4 is negative 1. At this point here, we need to add 1 to both sides, telling us y is equal to negative 1/4 x. Any questions on how we got it into point slope form? Or not slope, point slope, slope intercept form? Yep, so we have one of the two forms, slope intercept. Now it also wants it in standard form. Standard form, one of the main things is that x and y are on the same side of the equation. So if we're starting with this here, first thing we need to do is add 1/4 x to both sides, which just tells us that 1/4 x plus y is equal to 0. In standard form, x is always first, y is second. Any questions on this here? Now with most things in mathematics, this one here kind of holds true to most of y'all's suspicions that a lot of things aren't as easy as they always seem. There's always has to be something to them. For standard form, they do have a few rules. One, A, B, and C. Our coefficients cannot be fractional or decimal. We can't have them as fractions or decimals. Which means for us here, the only fraction we have is 1/4. What can I multiply 1/4 by to get it to be a whole number? 4. Which means I have to multiply the whole equation by 4. And nicely, 1/4 times 4 is going to be 1x plus 4 times y is 4y is equal to 0. The second rule that we have is that the value in front of x has to be positive. It can't be a negative number. Here, it is positive, so we're good there. And those are the two main kind of rules with these. The value in front of x has to be positive, and we can't have fractional numbers in any of them, fractional or decimal. So standard form is this here. And that's it. If we had more than one fraction, if x and y and our coefficient all were fractional, we'd have to see what number we needed to multiply all three by to get them to simplify down. But that is it there. Any questions on any of this here? Write an equation of the line passing through the point 2, -3, and it's perpendicular to the line defined by y equals 1/2 x minus 4. Write the answer in slope-intercept form and standard form. The nice thing about this one is they already gave it in slope-intercept form. So it tells us what the slope is, and the slope is 1/2. So our new slope, since it's perpendicular, is the opposite reciprocal. Change the sign and flip it. Since the 1/2 is positive, our new slope is negative. Since it was 1/2, if we flip it, it becomes 2/1, or we can just say 2. So the perpendicular slope to 1/2 is really just -2. And if we multiply those together, we do get -1. Two slopes are perpendicular if the product of them is -1. So we can start off with finding it in point slope form. And we can go from there. Now if we plug the point in, -3 for y, -2 for our slope, and 2 for our x value, we get this here. Now if we do some simplifying, the negative and negative gives us y plus 3. Distributing the -2 would give us -2x plus 4. At this point here, we just need 2 minus 3 from both sides, telling us y equals -2x plus 1. That's it. That's point slope. Or slope-intercept. Slope-intercept form. Now we also need it in standard form. Standard form, the x and y are on the same side. So from this equation here, we can just add 2x to both sides, telling us that 2x plus y is equal to 1. Now if we look at this here, are the numbers in front of x and y and the number by itself, are they integers? Do we have any fractions or decimals? Well, no. So, okay, that's good. Is number in front of x positive? Yes. So that's it. That's all we have to do. Any questions on any of this here? Yeah. We have a few more here. We'll talk about applications of them. But the only other thing on the homework with parallel and perpendicular that we will have for sure is it will give you 3 equations. Most likely one of them is going to be point slope, one of them is going to be slope intercept, and they probably are going to throw one in that's standard. 3 different equations, and it's asking you which ones are parallel, which ones are perpendicular, and which ones are neither. So the best solution I would say to that is get them all in the same form, as in y equals mx plus b, our slope-intercept form, and then compare the slopes. Let's look at this one here. A family plan for a cell phone has a monthly base price of $99, plus $12.99 for each additional family member beyond the primary account holder. Write the linear function to model the monthly cost, C of x, in dollars of a family plan for x additional family members needed. So base monthly price of $99 plus $12.99 for each additional family member beyond the primary account holder. So we're saying C of x is equal to what? $12.99 times x plus 99. Because if there's no zero additional family members, it's just the base price of $99, yes? And if we plug that in, we can check and make sure that does hold true, because $12.99 times 0 would be 0, giving us just the $99. So do we have the equation for A? Yeah, it's just the basic linear function. Evaluate C4 and interpret the meaning in the context of the problem. So C of 4. That's all we're saying is that we're replacing x with 4, so we're plugging it into the equation. So we'd have 12.99 times 4 plus $99. And we can plug this into a calculator, let it do it for us. Because most likely we would tell the calculator anyways to do $12.99 times 4 and then add 99 to it. Make sure, yep, 96. So we find that it's 150.96. Now, the interpret the meaning in the context of this problem seems a little weird. All it's saying is that it's going to cost the family what? $150.96 a month to have 5 people on the plane. Because we have the original holder, the primary holder, and 4 extra people. So for a 5-person plan, it's $150.96 a month. Any questions on this here? Are you ready for the next one? So linear cost functions models the C of x to produce x items. We have something like this here. The fixed cost does not change relative to the number of items produced. For example, cost to rent an office is a fixed cost. The variable cost per item is a rate at which cost increases for each additional unit purchased. Variable costs include labor, material, shipping, stuff that doesn't change based off of the size, where you're not getting a discount or increase in rate because of the number that are used. Something that wouldn't work with this here, we're talking about miles per gallon in a car. That's not going to be linear. That's not going to be constant, technically speaking. Because if you're driving a car, the faster you go, the more air resistance you're going to meet, which means the car is going to have to go faster or produce more energy to overcome that. So it's not a steady rate over time. Same thing's true with pitching a ball or pitching a softball. Just because you increase the overall speed does not mean, or the overall power behind the ball, does not mean that the speed of the ball will increase the same amount as you increase your pitching speed. Those are not going to be the same, if that makes sense. Because there's a whole lot of variables that go into it and it's not constant. Revenue is also 1 for the most part. But are there any questions on any of this here? In that case, I'm going to let y'all use the rest of the time to work on the assignment or assignments